In this video, we're going to talk about factorization of difference of square. Now, a difference of square is a perfect square subtracted from a perfect square. Now, in our previous video, we started with factorization of polynomials. Now, you can recall that a difference of square can be rewritten as a factors containing the same terms but opposite signs, because the middle terms can cancel each other out when the two factors are multiplied. That is, when you have a squared minus b squared. So a squared minus b squared should be equal to a plus b multiplying a minus b. So we can use this equation to factor any difference of square. So note that a difference of square can be written or rewritten as two factors containing the same terms but opposite, which is if you have a squared minus b squared, which I wrote earlier on, should be equal to a plus b multiplying a minus b. So how do we do this? Now, the first thing that you need to do is to confirm that the first and the last term are perfect square, right? And the second thing that you need to do is to write the factored form as a plus b multiplying a minus b. Now, let's take an example. With this example, we can see that we are going to factor 9x squared minus 25. So how do we do this? So we said we need to figure out or confirm that the first term and the last term are perfect square. So we can see we have our 9 and 25, and both of them are perfect square. So we can factor them. So with this one, because 9, which is perfect square, so 9x squared is equal to 3x into bracket squared, right? And 25 is also equal to 5 squared. Now, the polynomial represents a difference of squares and can be written as 3x plus 5 multiplying 3x minus 5. Very simple. Very, very simple to do, right? Now, I want to ask this question. Is there any formula to factor the sum of squares? Is there any formula to factor the sum of squares? What should be your answer? Now, the answer is no. The sum of the squares cannot be factored. The sum of the squares cannot be factored. Just note that. Now, let's talk about another thing here. Factorization of the sum and the difference. Let's talk about that. So that's factorization of the sum and difference of cubes. That's what we're going to talk about here. Now, we look at two new special products, which is the sum and the difference of cubes. Now, although the sum of squares cannot be factored, the sum of the cubes can be factored into binomial and trinomial, which is if you have a cube plus b cube, this a cube plus b cube can be also be written as a plus b, or can be also be factored as a plus b multiplying a squared minus ab plus b squared. Similarly, the difference of the cube or the difference of cubes can be factored into binomial and also a trinomial, but with a different sign. So if you have a cube minus b cube, can be factored as a minus b multiplying a squared plus ab plus b squared. Very simple. So we can use the acronym, which is SOAP, to remember the sign when factoring the sum and difference of cubes. So the first letter of each word relate to the sign. So we have S, which represents same, O as opposite, A as always, and P as positive. For example, let's consider this example. If you have x cubed minus 2 cubed, right? When we factor that, we should get x minus 2 multiplying x squared plus 2x plus 4, right? So the sign of the first two is the same as the sign between x cubed minus 2 cubed, right? So the sign of the 2x term, so the 2x term right here is the opposite the sign between the s cubed minus 2 cubed. And the sign of the last term, which is 4, is always positive. Let me go over again. So the sign of the first two is the same as the sign between the s cubed minus the 2 cubed. And the sign of the 2x term is opposite the sign between the s cubed minus the 2 cubed. And the sign of the last term, which is the 4, is always positive. Very simple. So, how do we do this? How do we do that? Now, the first thing that we need to remember is confirm that the first and the last term are cubes. When you get cube expressions, the first thing that you need to do is to confirm that the first and the last term are cubes, which is a cube plus b cube or a cube minus b cube. This is what you need to confirm. Now, the second thing that you need to do after confirming is, for a sum of cubes, rewrite the factored form as a plus b multiplying a squared minus ab plus b squared. And for the difference of cube, we write the factored form as a plus a minus b multiplying a squared plus ab plus b squared. That's what we do. So remember these expressions or these factored forms. Right, now let's take an example. So with this example, we are going to factor s cubed plus 512 here. So from our how to do things, we said the first thing that we need to do is to confirm that the first and the last terms are cubes, right? So with this one, we can note that s cubed and 512 are cubes because 8 cubed is equal to 512. And we rewrite the sum of cubes as what? Which is x plus 8, right? So the x and the 8, then multiplying x squared minus 8s plus 64. Very simple to do. Very simple. Now, after writing the sum of the cubes this way, we might think that we should check to see if the trinomial portion can be factored further. However, note that the trinomial portion cannot be factored, so we do not need to check that. We do not need to check that. Just leave it as it is, right? Now let's take the second example. In our second example, we are going to factor 8s cubed minus 125, right? Now we can note that 8s cubed and 125 are cubes, right? We can see that this a cube and this 2 is a cube, so we can go ahead and factor it. So what is the cube of 8x cubed, which is 2x? How do we factor that? That's 2x cubed, and 125 is 5 cubed. So write the difference of the cubes as 2x minus 5 multiplying 4x squared plus 10x plus 25. Very simple. Very, very simple. So you can just follow that and use to do that. It's very simple to do. Now, the last thing that we need to talk about is factorization of expression with fractional or negative exponents. So, with this one, expression with fractional or negative exponent can be factored by pulling out the greatest common factor, which is the GCF. Now, look for the variable or the exponent that is common to each term of the expression and just pull out that variable or exponent raised to the lowest power, right? Now, these expressions follow the same factoring rules as those with integer exponents. For instance, if you have 2x exponent 1/4 plus 5x exponent 3/4. Now, with this can be factored by pulling out x exponent 1/4 because that's the lowest term, and can be written as x exponent 1/4 multiplying 2 plus 5x exponent 1/2. Very simple. Just pull it out, right? Now let's take an example here and see how it works. So for this one, we have 3x multiplying x plus 2 into bracket raised to the power negative 1/3 plus 4 multiplying x plus 2 raised to the power 2/3. So how do we factor this? So we have to factor out the term with the lowest value of the exponent. So in this case, that will be what? Which is x plus 2 exponent negative 1/3. So that is the lowest value of the exponent. So we can pull that out. So when we pull it out, what do we get again? So we pulling it out, we get x plus 2, rewriting that, which is negative exponent negative 1/3 multiplying 3x, right, plus 4 multiplying x plus 2. Very simple to do. Very simple to do. So here we just factor out the lowest value of the exponent, then we factor and simplify. So with this one, when we go ahead to simplify, we should get x plus 2 exponent negative 1/3 multiplying 3x plus then 4x plus 8. All right, we go ahead and simplify. We can still simplify. So when we simplify, we should get x plus 2 exponent negative 1/3 multiplying 7x plus 8, and we get our answer. Very simple to do. Very simple to do. And I hope you got this. And this is the last video on factorization of polynomials. See you in my next video. Thank you for watching.